bop. I am a robot. Take me to your leader. Oh, it's math lesson time again. Guys, guess what I found up at e-school today? A robot. Yep, that's true. We used to have these a long time ago, but it's been a while since I got to see one or play with one, and it's got like these cool like vision eyes down here, and all these like moving arms and parts, and like this screen with like all sorts of cool stuff you can do. And as much as I would like to teach you a math lesson today, robot. So I'm gonna play with this for a little bit and have some fun with it. I want you guys to go ahead and watch this video from Brain Pop about the order of operations. I think that's going to teach you everything you need to know today. So I'm going to play with this. You watch the video. You should be seeing the link showing up in just a second. So enjoy that, and then maybe if I get bored of this, we'll come back together and talk a little bit of math. But for right now, I got games to play with my robot. So check that link out, and then we'll get back together in a little bit. All right. I am a robot.
Three times the sum of 26.
Alright guys, well I hope you enjoyed that video because I've got a bit of a conundrum on my hands. As you can see, my robot is making some very loud noises, and I can't figure out what's going on. Evidently there was some sort of like security alarm or something on this, and now it just keeps chanting this like same code over and over and over again, and it's deafening and it's driving me insane. So I don't know what the code means, and I don't know what it's trying to say, but let me go like stuff this under some pillows or something somewhere so I can try to think straight, and maybe you guys can help me figure out what this means. Okay, just give me 1 second. I'll be right back. Let me just find a place to maybe put this down under the. Get there. Okay, that is much better. Whew, all right, much better. I can still hear it a little bit in the background, but I think we'll be okay. So, really bizarre, right? Somebody must have put some sort of like security code on that robot, and now it's just chanting those same things over and over. Not really sure what they mean. Kind of sounds like math to me though, so I'm hoping you guys can maybe help me figure it out. We could take a deeper look at this and see what's going on, and what maybe math has to do with what this robot's saying. So if you would do me a favor, grab yourself something to write on, something to write with. We're gonna do some math, try to figure some things out, and see possibly what these codes have to do with what we've been learning about math and multiplication and division and order operations and those types of things. So once you got your stuff, you're ready to go ahead and click continue, and we'll keep rolling. Alright, so before we get moving, trying to figure out these codes that this robot was spitting out and see if we can decode some things and unlock it so it stops making that horrible noise. We're actually going to review a couple vocabulary terms, and it's been a while since we've done some vocabulary, and I got a lot of vocabulary to kind of start us off. So if you would, go ahead and cue the music. Math vocabulary. Man, that song never gets old, does it? All right, so let's take a look at some vocabulary words. Make sure you have out something, maybe get your math binder, jot these words down somewhere that you're going to remember them, and then can refer back to them if you need to, okay? So the first word we're going to take a look at is sum, okay? And sum is a word that we use when we're adding two or more numbers. So if we add two or more numbers together, we call that the sum, okay? Next up would be difference. So this would be when we're subtracting, okay? If we're going to subtract one number from another, that's when we're finding the difference, okay? Or if we're talking about how much one number differs from another, that's when we could use the difference as well. So again, thinking about this, the sum, if I added two numbers like 2 plus 2 equals 4, 4 is our sum, okay? These two numbers are called the add-ins, but what we get as the answer, that's called our sum, okay? And when we're talking difference, if I have like 5 minus 3, I'm subtracting 3 from 5, 2, our answer of 2, that's the difference, okay? That's the difference between those two numbers. The solution to a subtraction problem is called the difference, okay? We also want to think about the product, okay? The product is when you multiply two or more numbers, okay? So the answer that you get when you multiply two or more numbers, that's called the product. And then when we're talking about division, that's the answer you get after you divide one number by another, okay? So if I were to multiply two numbers, again, let's say 2 times 3, that would give me 6. So this is my product. The 6 is my product. The answer is my product. These two numbers are the factors, but 6 is the answer that's called the product, okay? And when we're talking about dividing, and let's say 9 divided by 3, well, 9 divided by 3 is 3. So this answer right here, that's going to be our quotient. The answer to a division problem is the quotient, okay? So these are just kind of a review. You should know these terms. These go way back to like first, second, third grade, somewhere in there. So you should know these terms. Is just kind of a little bit of a review. Some new terms that are coming at you are these guys. First up, we have parentheses. Now, this hopefully isn't a brand new term. Hopefully you've heard of this before, especially when it comes to writing. But in math, we use them as symbols to pair numbers together, or pair groups of numbers together, or just pair things together in math. For example, here we've paired 3 plus 2. We've paired that like problem together, and then the 6 minus 4, we've done that there. So we've kind of grouped those numbers and operations together. So this 3 plus 2 is something we grouped, so we would do that together, and then this together, and then multiply them after the fact, okay? So that's what parentheses stand for in math. Another term that you might have heard of, but it might also be new to you, is called expression. Now, an expression is basically just numbers, symbols, and operators. Operators being like a plus sign, or multiplication or division or something like that, that are grouped together to show the value of something. So commonly when you see an expression, it's not going to have an equal sign to it, okay? It's just going to be some numbers and some symbols kind of grouped together. For example, you might see something like this, 2 plus 3. That's an expression, okay? There's no equal sign there. There's nothing, not a solution that we need to find necessarily. It's just kind of like a sentence written with numbers and operators and symbols, okay? Here's another one. This is a little more advanced, but this is 3 minus x plus 2. So we got a variable in there, and we're dividing by 2. I'm sorry, x divided by 2. So you can see that's another expression. There's no equal sign. It's just some numbers and some operations and stuff grouped together, okay? And another word that we're going to be working with, and I think this is our last vocabulary term for today, is called evaluate. So when we see an expression, we can evaluate an expression. We can basically find the meaning of it, find a different way to write it without necessarily finding an answer, because there's no equal sign, okay? We're just evaluating these expressions. So we're kind of finding a solution to it, okay? So example would be 3 times 26 plus 4. Well, we could evaluate this and we can find the different parts of it. So we could do 26 plus 4. That would give us 30. And then we could times that by 3 to get 60. So we can say that this expression is also worth 60. Okay, we're not saying it's like equal to. If it said equal to, then we could definitely solve it. But we're evaluating it when there's no equal sign involved. I know it's kind of semantical. There's not really a huge difference in those things, but just I want you to kind of keep that in mind, that we're finding other ways to express this expression that we have here when we evaluate something, okay? All right, so how can this help me solve this code that the robot keeps spewing out on this repetitive, super annoying loop here? So what I'm thinking is we can actually evaluate the code that he's saying, kind of find some solutions to it, and then I can input that and see if maybe that shuts him up. So one of the things that he keeps saying repeatedly is this. Okay, so one of the things he keeps repeating is 3 times the sum of 26 and 4. 3 times the sum of 26 and 4. I don't have any idea what that means yet, but let's kind of dive in a little bit deeper and explore what it is he might be trying to say. So looking at these 3 boxes here, right? I have 3 boxes. And let's say for the sake of it that one of these boxes is worth 5. Okay, so this box is worth 5, this box is worth 5, and this box is worth 5. What kind of expression can I write to show the value of what I have here? To show the total value of these 3 units? All right, well I could write that as 3 times 5, right? So I have 1, 2, 3 boxes, and each one of those boxes is worth 5, so I'd be doing 3 times 5. I could also do it as 5 times 3, because we know the commutative property. We can switch those, right, and would still get the same answer. So I'm going to stick here with 3 times 5. That could be an expression to kind of describe the value of these units, okay? All right, that makes sense. I can see that. But what if I did this? What if I took out the 5 and instead I wrote in a variable like a? So we don't really know what the size of it is. We know that the size is a. Could I still write an expression to show or to define what the value of those boxes are? I could. I could just say 3 times a, right? So if we found out whatever a is, if I did that 3 times, that would give us the value of this, right? All right, cool. So far, so good. How can I use that knowledge to help me with this? Think about that for a second. How could I use what we've kind of set up here to help me with this? 3 times the sum of 26 and 4. Well, what if instead of saying a, I said 26 and 4? Meaning that whatever 26 and 4 is, if I did that 3 times, I would find the value of this expression. 26 and 4. Mind blown, right? It's kind of a weird kind of concept to wrap your head around, but I can do that. I could say the sum of 26 and 4 3 times, right? It's the same sort of thing. 3 times the sum of 26 and 4. So if I found the sum of 26 and 4 and I did it 3 times, that's how I could show that expression, right? I just kind of use these boxes to help me frame that a little bit. So I can write this sentence, this phrase, as an expression of 3 times 26 and 4. Because what it's saying is 3 times the sum of 26 and 4. So I would have to find the sum of 26 and 4 first, and then do it 3 times, okay? So tell me real quick, now that I kind of said it, but why is it important to put these parentheses here? And I will say that it is important. It is necessary for this expression. Why do you think it's important, though? What makes it important? Why do we need to put those parentheses there? Well, exactly. If you read in what this phrase actually says, it says 3 times the sum of 26 and 4. So we need to find the sum first and then do that 3 times. So if we found the sum of 26 and 4, that would give us 30. And then we would need to do that 30 3 times, right? So we can evaluate this expression and do 30 3 times. So I'm actually going to do like this. 3 times 30. So if we did our 26 plus 4 there, that gave us 30. And then 3 times 30 would give us 90. So if we evaluated this expression of 3 times the sum of 26 and 4, we would get 90. All right, so I think that's one of the codes that I'm going to need for the robot here is 90. I'm going to have to input that in and see if that helps to quiet him down a little bit, because he's getting annoying and I'm starting to hear him through the pillows that I stuffed him in the box I put him in. I think he's getting back at me. He's getting louder. So let's see what the other phrase was. Let's see if we can figure out what that means and see if that helps as well. All right, so the other phrase that the robot keeps repeating is 6 times the difference between 60 and 51. So, again, this is kind of like the last phrase he was saying. So it's an expression, right? It's the verbal form of an expression. So we want to figure out what the numerical form of it is, so that way we can solve it and put that in as a code to maybe stop him from repeating that. So let's take a look here and see what we have going. We have 6 times the difference between 60 and 51. So I went ahead and drew 6 boxes out here because I know it's going to be 6 times something, right? Because that's what it's telling us at the beginning. 6 times the difference between 60 and 51. So I have 6 times what? What's going to be 6 times? Think about that for a second. Awesome. Well, I'm going to have 6 times the difference between 60 and 51. So that means I'm going to subtract, right? We talked about difference and what that means, and that means to subtract. So if I subtract those two numbers, 60 and 51, and I find the difference, I'm going to do 6 times the difference between 60 and 51. So if I subtract those two numbers, well, I'm going to get 9. And I'm going to have to do that 6 times, right? Because our expression says 6 times the difference between 60 and 51. And before I actually solve that and start writing things out, let's write a numerical expression to represent this. So again, we're going to have 6 times something, 6 times the difference between 60 and 51. And I'm going to have to put that 60 minus 51, okay, to find the difference. I'm going to put that in parentheses because I need to find 6 times that, okay? So what is the difference between 60 and 51? Right, it's going to be 9. So 60 minus 51 is going to be 9, but I want to find 6 times that, so I'm basically finding 6 times 9, and 6 times 9 is going to give me 54. So I know that this expression can be evaluated to the number 54. Okay, I can bring it all the way down to 54. So I'm going to go ahead and type those codes into the robot to see if that helps to quiet it down, and I'll come back and check on you guys in a second, okay? All right, it worked. It worked. It's awesome. Oh, man, it was getting kind of annoying. So that was perfect. So we were able to evaluate those expressions, and I put in those numbers, and that quieted the robot down. But my only problem is now on the screen, it's flashing some expressions, and I think it's wanting me to say what that expression is, to like say it out loud, because it's asking me for a voice command. So let me put this guy aside for a second, and I'll write down what it's showing me. Maybe you guys can help me out with this too. All right, guys, so on the screen to the robot, this is what it's showing me, okay? I have this problem here of 20 times 3, or this expression, I should say, 20 times 3 plus 5 times 3. So I don't know exactly what it's asking me to find, or how I can evaluate this. So maybe you guys can help me out with this. So let's take a look at this in whole. So if I were to just kind of read this expression, right, I would read it as 20 times 3 plus 5 times 3. In thinking that, really, when you say that out loud, so let me just write that down real quick. So when I read that out loud real quick, it sounds okay, 20 times 3 plus 5 times 3. But when I write it down, 20 times 3 plus 5 times 3, if I were to just listen to that and not look at the expression that's written above it, I would write it as 20 times 3 plus 5 times 3, which looks the same except for what? What's it missing? Right, the parentheses. And those parentheses are telling us to do something first, okay? We have to do what's in the parentheses first. So this phrase isn't telling us to do that. So how can I rephrase it to make sure that we're doing what's in the parentheses first? Well, let's break it down piece by piece. What are the parentheses looking or asking for us to do here? Like, what is this saying? Well, it's looking for the product of 20 and 3, right? So we could say the product of 20 and 3. So that's going to take care of that portion. The product of 20 and 3. Okay, cool. What about these parentheses here? What are they asking us to find? Well, again, they're asking us to find the product of 5 and 3. All right, so we got the two parentheses taken care of here. But what is it asking us to do with those products? We're going to have to do what? Add them, right? So we're going to want to add both of those products together. So what's the key word that we know that means add? Sum, right? So we can say the sum, right? The sum of the product of 20 and 3 and the product of 5 and 3. Pretty wordy, I know, but that's going to tell us exactly what is written up there. The sum of the product of 20 and 3 and the product of 5 and 3. So writing it that way is going to tell us to do exactly those steps and arrange it in the way it needs to be arranged in order to find it. Because if I were to do 20 times 3, well, let's just do it real quick. If I did 20 times 3, that would give me 60, plus 5 would give me 65, times 3 would give me 195. So that's if I just read it straight across, right? Which is what we did the first time. But if I do it this way and I find the product of 20 and 3, which would give me 60, and I find the product of 5 and 3, which is 15, and then I find the sum of them, the sum of 60 and 15, well, the sum of 60 and 15, that's going to give me 75. So 75 and 195. A little bit of a difference. So the phrasing definitely matters in how you put it together, okay? Okay, and there are a couple different ways to phrase this if we wanted to. Like we could say the product of 20 and 3 plus the product of 5 and 3. That would be another way we could write it. We could also write it as the sum of 23s and 5 3s all different ways to interpret it, but we definitely want to make sure that whatever way we're phrasing it, that we're getting everyone to do what's in the parentheses first and then adding those together, okay? So let me try reading these to the one of the robot, to the robot and see if that helps. So the sum of the product of 20 and 3 and the product of 5 and 3. All right, I got a check mark. Yeah, it must mean I'm right. Give me another one. All right, let's look at one more real quick. Maybe you guys can just give me the answer and help me out, and hopefully I can unlock this, turn them off, and send it back to eSchool, because I don't want any more math problems with this robot. Okay, this time on the screen, he's showing this. So it looks like 8 times 43 minus 13. Now again, we have these parentheses here, so it's telling me that the way I just read it, 8 times 43 minus 13, I can't do it that way. I have to do this 43 minus 13 first, okay? And then I can multiply it by 8. So how can we say that? How can we phrase that to make sure that happens? Good, well this is subtraction, right? So I could say the difference of 43 and 13 times 8. All right, and that will give me what we're looking for. So the difference of 43 and 13, I'm going to find that first, and then I'm going to multiply it by 8 or times by 8. Okay, so let me try that one real quick. The difference of 43 and 13 times 8. Another check mark. Awesome. All right, before we go any further, I am turning this guy off.
I'm sorry, Dave. I'm afraid I can't do that.
That's weird. Let me try one
This
more time.
mission is too important for me to allow you to jeopardize it.
Okay. Looks like I got some bigger problems on my hands here. So I'm going to let you guys practice with some of these problems. Me and the robot are going to have a friendly little discussion. But if you guys need anything else, please let me know. I'm here to help. So practice with your expressions. Practice evaluating some expressions and writing some expressions on your own. And wish me luck. All right, guys. Talk to you soon.